Well, hello there, Jedi Knights, Go Mathers. This is your Tuesday version of your Math Spiral Help. And let's see, I have a bunch of things open. Sorry about that. Um, Today, before I even start with helping you through some of these, I thought I would say a couple things. Number one, today, this afternoon, I went for a bike ride with Julia and Liam, and we went on a few paths through a little forest area not too far from our house called Riders Woods. And it was really fun and really good and just so great to get some fresh air and move our bodies like that. So I just want to make sure I encourage you to do the same. So whether it's a bike ride or a walk or a jog or a ball game that you can do on the side of your house or something, even if you're by yourself, just make sure you get outside and get some fresh air. It does a lot of good for you. And then the second thing I wanted to make sure I said was, please join me at 11:30 each day to do a Google Meet for I'll Focus on Math Help, because I will be there to help you first through your Go Math work for that day and then Math Spirals. Okay, so I want to see you there. So if it's Tuesday, Google Meet time, you would type in into Google Meet Ledig Tuesday Math Help. Boom, and you'll be in. Okay? If it's Wednesday, Ledig Wednesday Math Help. Okay? All right. So today I thought for Tuesday I would do these problems here because I still see some kids turning in the answers that are not quite correct on adding and subtracting fractions that have unlike denominators. So I thought we'd keep on focusing on that. So my first help will be on 2/7 plus 1/3. And when you have denominators that are different, you need to change them into equivalent fractions. That is, so for here, something that's still equivalent to 2/7 but has a same denominator as whatever we come up down here. So for 2/7 and 1/3, I'm just going to use a strategy where I use the opposite denominator. Okay, so for this one, I see that the 3 is the denominator. So I'm going to multiply both the top and the bottom by 3. And then I will end up getting 6/21s or 6/21. Okay, 6/21 is equivalent to 2/7. Okay, so if I give Julia 2/7 of a chocolate bunny, but I give Liam 6/21s, and it might sound like I'm giving Liam more. It's not. We're still the same amount. Down here for 1/3, the opposite denominator is a 7, so go ahead and multiply it by 7s. 7 over 7, and then you will get 7/21. So I did 1 times 7 is 7, 3 times 7 is 21. This is an addition problem, so just add your numerators only. 6 plus 7 is 13, and the denominator stays the same. 13/21, that's the final answer for that one. And 13 is a prime number, can't be divided by anything, just keep it. For 6/9 minus 1/5, let's go ahead and do that strategy of multiplying by whatever the opposite denominator is. So for 6/9, I'm going to multiply it by 5/5. Okay? And for the 1/5, I'm going to multiply it by 9/9. All right. 6 times 5 is 30. And 9 times 5 is 45. And over here, 1 times 9 is 9. And 5 times 9 is also 45. Now we have those like denominators, so now we can subtract away. 30 minus 9 is, you're doing the work with me, 30 minus 9, you get 21, and then denominator stays the same. Now for this one, I think I'm thinking of a number where they both can be divided by. 21, if I think of 3s, and I think the multiples of 3, I would land on 21. And that's also going to happen if I think about 3s, I will eventually land on 45. So these both can be simplified by 3. So I'm going to divide both of those numbers by 3. 21 divided by 3 ends up being 7. And 45 divided by 3 ends up being 15. So you always want to give the simplified answer when you can find one. So for that one, you want to type in 7/15 for your answer there, okay? And let's see. The other one, I guess, I was going to do was kind of just talk about a couple of these. This one here, guys, make sure that you move the decimal twice. 1, 2, so it's after the 3, which means you have to do the decimal twice here as well. So move it twice. So then it turns out to be 3.9 divided by 3. And then you should get an answer that's 1 point something for that one. And then don't let these trick you up. The 4/5 divided by 7/8, don't let that trick you up. That's KCF. Keep, change, flip. Keep the 4/5. Change the division to multiplication. And then flip the 7 and 8, so it's 8 and 7. And now you just have to do 4 times 8 and put your numerator. And on the bottom will be 5 times 7. And then you have your denominator. Okay? And if it's improper or the numerator is larger than the denominator, then I want to see you try and simplify it down into a proper mixed number. All right. So, and then the last one I'll do quick, is moving our decimal. And we've got 5 and 34 hundredths, and we have that 4 times. But we're multiplying it by different things each time. This first one, we're dividing by 100 for that one. And this one's dividing by 10. But look at the pattern gets messed up here. It's not going to divide by 1. That's too boring and lame, because if you divide it by 1, you just get the same number. So pushing ourselves, divide by 1/10 and divide by 1/100th. Okay, so I wish I had my blue marker. I don't know where that went, but I don't think you'll see the orange marker. We'll see. I'll check. 5 and 34 hundredths divided by 100. Divide means I'm going to find smaller groups. So I know I'm going to move the decimal to the left to make this 5.34 smaller, because I'm dividing by 100, dividing up into 100 bags of it. It's going to be a small number. See how there's 2 zeros in 100? So that means move the decimal twice to the left to make it smaller. So now it's not 5 and 34 hundredths. No, it's not. Yeah, I can barely see that. You want to move it to the left twice. So 1, 2. So put a 0 up in the front of it. That's where your decimal goes. And a 0 in front of that too. So it ends up being 0. And then your decimal, another 0, 5, 3, 4. So this is tens, hundredths, thousands, 10,000. So 534 10,000s. Whoa. Okay. Now, for this one, 5 and 34 hundredths divided by 10, again, dividing, so it's going to get smaller. So we're going to go to the left. And there's 1 0. Okay. So for this one, you're only going to move the decimal only one time. And the one up here, we moved it twice. So it's not going to be 5.34. I just have to move it one time to the left. Okay, only one time to the left, which will then make it just move right in front. So now you get 0.534, which then turns into 534 thousandths. Now for this one, I'm going to challenge you to think about it like if it was 5 and 34 inside the division equation as the dividend, and the 1/10 on the outside. Remember when the 1/10 on the outside and there's a decimal, you have to move it out of there? So you'd move it 1 to the right, which means move the decimal to the dividend 1 to the right. So let's just do that, because guess what it ends up being then? 53.4 divided by 1. Easy. 53.4, or 53 and 4/10. Done. Same with this one. What if we had 5 and 3/4 divided by 1/100th? You have to move the decimal twice for that one to get it out of the dividend. So move it twice here. So then it just turns out to be 534 divided by 1. Haha, that's easy. 534 divided by 1, 534. Voila, that wasn't bad once we remembered that rule. Okay, and then when you're looking at what is the difference between a hexagon and an octagon? Well, they're both polygons with many, many sides. And if you keep on moving up, you've got triangle. Then we have a square or a rectangle or a rhombus. And then after we go and then we can do like a square. This is 3 sides, square has 4 sides. Then what has 5 sides? A pentagon, right? Pentagon. There's a lot of 4 sides figures we can think of, right? I already rattled off a few of them. Rhombus, parallelogram. 5 is a pentagon. 6, you know what 6 is? 6-sided shape. A hexagon. 7. Do you know what a 7 is? A 7-sided shape. Septagon. And 8-sided shape, think of a stop sign. Octopus, 8 legs. Octagon. So your question was, what's the difference between a hexagon and an octagon? Psh, you know it. You can do it. All right, there's your help for Tuesday. Love to see you at 11:30 for our Google Meet.